In this last lesson of C++, we are going to talk about the copy constructor and the assignment operator overloading. Let's start by using a default copy constructor. Basically, if we create an object, so let's make an apple, and we have this object now, we would have a default constructor because I didn't put any parameters there. So the name would be I'm an apple and the amount would be 0. Then I can make a second apple with the help of the first one. So I can make a second apple by using the first apple. And this is the copy constructor. And we get this default for any class. So I don't have to make anything myself. If I want to use it, it's there for everybody to use. So if I now would say A1 show, and I will do A2 show, then they would have the same content because A2 is created with the help of the first object. Let's see if that indeed works. Okay, I have two objects. I'm an apple with amount 0 and I'm an apple with amount 0. And they work independently of each other now. So they're really two objects. So to demonstrate that, let's put a new line in the middle. We can change the amount of one of the objects. So let's change the amount of A1. And we can do set amount. 33, and then show them again. So A1 show and A2 show. And then the content of A1 should have changed, but A2 is still the same. Okay, so indeed we created two apples with amount 0, one with the help of the other, and then they work independently. They're just two different objects. So I change the content of the first one and the second one then stays untouched. And so we have two independent objects. The standard copying system of C++ is a shallow copy. And what does that mean if we work with dynamic memory? Let's look at another example instead of our foods. So let's say we have a class crate, and this class crate has bottles inside. And let's say we implemented it with the help of a vector, and this vector contained pointers to bottles. And those bottles are created with the help of the new keyword, so it contains dynamic objects. So that means we put the responsibility for the life cycles of the bottles in the hands of this class crate. So we have to make sure that when the crate is destructed, we need to take care of destruction of the bottles. So remember to implement this destructor, just a simple for loop. So let's say the vector is called bottles, then we just run to the bottle vector, and every time we have one, we delete it and we free the memory. If we now use a copy constructor, the default one, then as I mentioned before, you will get a shallow copy. And that means that only the real variables, the private variables, are copied, but no dynamic memory is copied. So what would that do for our crate? So let's say this is our crate, and we have a vector of bottle pointers, and we would make a copy of them with a shallow version. Then all the direct parameters, all the direct variables in the crate object will be copied, including the vector with the pointers. So that's not a problem. But the pointers itself will stay pointing at the bottles from crate 1. So we get this image. And so we have two crate objects, we have two vectors, but both vectors contain pointers to the same bottles. In fact, that's of course not a real life happening. And that means if I drink the bottle from crate 1, then crate 2 immediately would have an empty bottle. So that's not working well. So what we should do is make a real copy constructor, not a shallow one, but a deep one in which we really create new memory and new bottles. So we want to have something like this. We have this crate, and then we just define our own copy. The crate is copied, and for every bottle inside the first crate, we will make a new bottle. So let's recap what we know about the factory. And so this factory header file, let's go there. And we'll start with the basic one, a factor with fruits, and not with the specific one with the virtual possibilities, but just a simple factory with a name and a vector inside there with fruit pointers. And in this factory we could give it a name with a constructor, we could ask for the name of the factory, and we could add a fruit just by giving it the name of the fruit and the number of apples or oranges or whatever we would like to do. And then we could also show the fruit inside the company. If I go to the implementation of this factory, then we had this constructor, and this name becomes S from this string. We had the destructor, remember, because we had a vector with pointers in there, we needed to delete all the objects related to those pointers. We had a get name, and we had an add fruit. And this add fruit, let's look at this a little bit closer, got a string for the name of the fruit and an amount for the number of fruits we have. And how did we deal with it? We created a new pointer, and to this pointer we created an object of the type fruit, and we used the constructor with the string and the amount, and we pushed the pointer to the system. And remember, we used the old-fashioned fruit implementation without all virtual things, so just with a name, an amount, a getter and a setter. That was all there is to it. So in my factory, I could now, in my console application, I can now just make a factory. Let's do that. Factory, my factory, and let's use the name Fontis again. Fontis Fruit Factory. Okay, we can add some fruit in there. So my factory, add fruit. Let's put in an apple. Amount 20. And let's put in some other fruits as well. Some oranges. Amount 30. Okay, if I now would look at the content of this one, so see out content of my factory. And then I can just use the show method. Show all fruit. Okay, let's see if this works. So we build. Okay, so I have my factory with 20 apples and 30 oranges. And now I would like to make a copy constructor. So what I'd like to do is make a second factory. And so second factory. And I would like to have a copy of my first factory in there. So with the my factory. And then let's just prepare everything. So the content of the second factory. Okay. But as we explained previous, we have to make now a copy constructor. So let's go to the header file of my factory and create a copy constructor. So I have a public function factory, and this factory requires another factory to use. So we have a factory and give it as a reference, because this factory can be enormously big. So we always use the reference parameter mechanism to call it. Okay, so let's implement this one in the CPP file. Let's just do it just underneath the other constructor. So I'm making a constructor of factory. It is called factory because it's a constructor, and as a parameter it has a factory with a call by reference. Okay, so now what I need to do is make my own copy. So for the name I have no problem. So for the new object I can just get the name of the SF, of the factory given to me by the constructor. So the name. Okay, then I have to make foods. So let's make a pointer outside the for statement, and then for, and I have to go to the complete factor of SF. So for the size, for one integer starting at 0, going to the complete factory, so as long as the integer is smaller than the size of the my food factor, then I have to walk on I++. And what do I have to do for all of these elements? I have to make a new object food. So FP becomes a new food. FP becomes a new food. And this food has to be made with a name. And the name is found in the my food factor. And then on spot I, because I'm working with the ith element. And I'll ask him for the name. Okay, and the second parameter would be, of course, from SF my food factor at spot I, the amount. So now I'm making a new food with the same elements, the same values as I had in my original one given in the constructor. Okay, and then there's only one thing left for me to do. I have to push this copy, this new element, in my own vector. So in my food vector, and then let's use pushback, this FP. Okay, so that should do the trick. And so now I have made a deep copy for the factory. So if we go back to the application, and so I use it now, and let's see if it worked. And indeed, I have the content of my factory and the content of my second factory is identical. So I've made a real copy. And just to make sure that I really created new objects, let's say you say, yeah, I don't know whether that's true. Let's just use the number of objects created. I can ask the class food. Did I include the food header? No, let's do that. Otherwise I can't use it. So I will ask the class food for his number of objects. And we had the class function there. Get number of food objects. And hopefully we get as a result 4. Yeah, perfect. And so now you see we have 2 extra objects with the same content, and again I can change these objects if I like. Okay, for the second part of this lesson we will talk about the assignment operator overloading, and we'll continue in the next video.